After the ignition, we get a make at 600 meters and the apogee at 3,000 meters. On the descent, after 50 meters, the direction is deployment, and we decrease the rocket descent rate to 30 meters per second. And finally, 450 meters to the ground, the mission is deployment, and we decrease the rocket descent rate to 7 meters per second. The rocket is divided in a nose cone that contains the payload bay, open airframe that contains the main chute, avionics space, works a coupling and protects the avionics system, drop chute, and finally the motor airframe that contains the motor, pins, and a tail.
Regarding the margin of stability from the tip of the nose cone of the rocket, the center of gravity is located at 151 centimeters, and the center of pressure is located at 174 centimeters, resulting in a minimum stability margin of 1.6 and a maximum of 3.6. The total length of the rocket is 246 centimeters with a weight of 25 kilograms.
The rocket will have a solid propulsion system, which means that the oxidizer and the fuel are both in the solid state. In order to achieve the 3-kilometer apogee, we will employ a total propellant mass of 7.8 kilograms with a burning time of 2.8 seconds and with an specific impulse of 109.6 seconds. And we are expecting an operating pressure of 102.21 Cs. The crane will have a 3 centimeter of internal diameter and 11.4 centimeter of external diameter. The core configuration is space. For propellant, we will use sorbitol as the fuel and potassium nitrate as the oxidizer, and this reaction will be catalyzed with iron dioxide, which accelerates and increases the performance of the reaction. For thermal insulation, we will use PVC tubes. Here we can find the dimensions of the nozzle and the case. The nozzle will be made out of steel, and the case and lid will be made out of aluminum. To join the lid and the nozzle to the case, we will use snap rings and to seal O-rings. We designed each joint to have a lower safety factor than the case, in order to have a longitudinal failure mode rather than a radial one.
Nose cone has the following characteristics. The tip has von Karman series geometry, the tubular section of 30 centimeters plus a tip of 26 centimeters. The best aerodynamic configuration generates 33% less drag compared to a non-optimized configuration. Nose cone, bow tail, and fins. Dual deployment recovery system, the detonation of independent CO2 cartridges. Using a punch for the expulsion of the parachute activated by a SRAD encode system. Components, drop chute, semi-elliptical geometry, 0.8 meters, 30 meters per second. Main chute, 2.4 meters, 7 meters per second.
The Avionics division has focused on developing an Strat computer, which has a data acquisition system of altimeter, GPS, temperature, SD, and flash memory. Regarding telemetry, we have managed to send data to a ground station to know the flight status and data of the rocket. The advantage of the ground station is its versatility, since it can be transported without connection restrictions. The team has also focused on the characterization of a Moxon antenna. The use of COTS computers is a necessary requirement for the equipment due to the characteristics of these computers. It also has 3 pyrotechnic deploy channels and a barometric altimeter.